area of a sector and area of a segment. So before we get into that area business, let us define what we see here on the screen. So we have a circle with radius r. We have denoted angle theta and point P and point Q on the circumference. So this represents an arc A. Okay, so you are familiar mostly using degrees when working with angles. Now we will define a ratio where A will be divided by R as angle theta. When arc A is equal to radius R, then that angle A over R represents 1 radian. Only when the arc A is equal to the value of the radius R. So that's it. That is very important. Now, the circumference of a circle C is equal to 2 pi r. I need to refresh that. Area of a circle represented by pi r squared. So when the value of r is equal to 1, then you would have a unit circle. So the circumference of that unit circle would be 2 pi. So now we can make a connection that 360 degrees, when you complete the revolution from point P all the way back to P, will be related to 2 pi radians. And then further down you can say, well, 180 degrees will be related to pi radians. For an obvious reason, this half of it. Then you can find relationship between 90 degrees, 45, 30, 60. But when it comes to angles of various degrees between 0 and 360, so you want to use something that is practical. You can't memorize all those possible values. So this is what we can do. We can create a proportion. So if 180 degrees is equivalent to pi radians, so say if I want to find how many degrees is in 1 radian, so x degrees will be equivalent to 1 radians. So now I have a proportion here to work with. Find x from it. So cross multiply. So pi x degrees will be equivalent to 180 degrees times 1. So solve for x. So x will be 180 degrees divided by pi. And in the process, you will get that this is, when you use a calculator, x is equal to 57.2958 degrees. So 1 radian is equivalent to 57.2958 degrees. So we write that 1 radian is equal to 57.2958 degrees. So the unit on the left is in radians, on the right in degrees. So now we can convert any value in radians to degrees and vice versa. We can use the same proportion here. So whatever we want to get, we can start with the correlation between 180 and pi, or we can choose to do work with 360 and 2 pi radians, or even 90 and pi over 2. It's your choice. But in any event, you will be able to find the relationship between degrees and radians when you want to convert units. Okay, so let's go back to this diagram here on the screen, and what you will see that cutout shape, 0 OPQ rather. So this all shaded here are called sector. So that area, it's called a sector of a circle. Now, the bigger the angle theta is, the bigger the length of the arc will be, so the bigger of the area of the sector will be in the end. So there is a correlation between the angle theta and area of a circle, and area of the sector, I should say. So area of the sector is related to that angle theta. Area of the circle, pi r squared, is related to the entire angle in radians, 2 pi radians. So now we can define a proportion where area of the area of the sector to the area of the circle is equivalent to the ratio of angle theta over the entire angle, 2 pi radians. So let us move up on the screen and solve for area of the sector. So area of the sector, solve this proportion, so cross multiply. So pi r squared times theta. So let me keep theta in front. So theta pi r squared divided by 2 pi. So now you can see that we can simplify. So divided by pi divided by pi. So area of the sector now is equivalent to the following. 2 from the bottom, so in other words this is 1 over 2 times theta times r squared. So this is the area of the sector for any circle. So the area of the circle is completed. Now we will define a segment. So connect Q with P. So this little tiny area here, shaded in green, is called a segment. So to find the area of that segment, we need to cut out from the entire sector triangle OPQ. So area of the segment is found as the difference between area of the sector minus area of the triangle. So we know this, how to find area of the sector. How do we find the area of a triangle? So quickly recall the situation here. So what we have on the diagram, we have R, so that's O. Let's say this is P, this is Q. So that angle theta is measured here. So this will be the triangle. It is an isosceles triangle, but let us use the base as R and the altitude H, which is projected on that side R. So the classic formula for the area is 1 over 2 base times height. Excellent. Since B is equal to R, okay, by definition, let us find the value of H in terms of R and theta. So in this tiny right angle triangle, we can define the ratio H divided by R. H over R is equal to sine ratio of angle theta. So h is the opposite, r is the hypotenuse, and this remaining little portion would be the adjacent side. So then h is equal to r sine theta. So we have h value, we have b value, so let us put it together. So the area of the triangle OPQ now can be expressed by the following formula: 1/2 times base, which is r, times height, which is r sine theta, simplified, always simplified. So area of the triangle now is r squared sine theta. So, as we said, segment area is found as a difference between sector minus a triangle. So let's do it. So now we can say that area of the segment, so further down here, is equal to half theta r squared minus half r squared sine theta. Let's take a look at this expression. Common factors. So what is the same for both parts? 1/2, 1/2. That's the same. Also, we have term r squared. So the common factor 1/2 r squared can be factored out in front of brackets. So 1/2 r squared. So what goes inside? Theta minus sine theta. So this completes the area of the segment. So we have area of the segment, we have area of the sector. So now we can put things into practice. So okay, now the radius r is 2 centimeters long. The angle in between is 45 degrees. So the challenge here is to find the area of the sector and the area of the segment. So area of the sector, if you remember, that's the pizza slice, OPQ. So this is 0.5 or 1/2 theta r squared. Area of the segment is equal to 1/2 r squared theta minus sine theta. So everything seems to be straightforward. So almost. You wish to plug in into the equation the value of r, the value of theta, and go for it. However, there is a catch here. The degree unit cannot be used to find the area. So we have to change into radians. So this is very important. You must be aware of that. Many times you may be given a question to find the area of a sector. The angle in between two radii is in degrees. Common mistake, people plug in and get the wrong answer. So change into radians. So 45 degrees. So quickly, let us recall how do we do that. So the proportion 180 over, now I have degrees, so 45. So 180 is equivalent to pi radians, so pi over x radians. Solve that proportion. Cross multiply. So 180 x is equal to 45 degrees pi. Solve it for x, so divided by 180. 180 divided by 180, so x is equal to 45 over 180 degrees pi. Now, can't leave it like that. Needs to simplify further. So 180 and 45 goes 45 4 times into 180, so this is why you get pi over 4 radians. So this is very important step to convert the degrees into radians. Once I have it, this is very easy to continue. So area of the sector is now 1 over 2 pi over 4 times 2 squared. Area of the segment 1 over 2 squared in brackets pi over 4 minus sine pi over 4. So one more thing, sine ratio of 45 degrees or pi over 4, this should go back into unit circle, unit triangle if you don't recall that, and the value of that is 2 root 2 over 2. Okay, so say if you don't remember that, so quickly identify a unit triangle with side 1, 1 and square root 2 by Pythagorean. So 1 squared plus 1 squared is equal to 2, so square root of that is square root 2. So sine ratio will be 1 over root 2. When you rationalize, you multiply this denominator times square root 2 times top square root 2. This is why you get root 2 over 2. So having that ready, substitute into the formula and simplify. So you have 4 divided by 2, 2 outside, pi over 4 minus root 2 over 2, common denominator, times 2 times 2. So remember, times 2 times 2. So now you will have pi minus 2 root 2 over 4. And now you need to simplify it further, so you divide it by 2. This is why you have pi minus 2 root 2 over 2. So the area should be expressed in centimeters. So area of the segment is equal pi minus 2 root 2 divided by 2 centimeters squared. So this is the exact format. Go back and simplify the area here. So this is 4 divided by that 4 is 1. So this is pi, just pi over 2 centimeters squared. So now pi represents a real number. So you would have to use a calculator, and if you want to change this to a decimal number. So using the calculator, this is the area of the sector in centimeters squared. This will be the area of the segment. So knowing the formula is one thing, but proper application is very important. So the key here is to understand that in this formula, angles are, the angle values that you're going to use must be in radians. So convert degrees into radians. If you have an angle in radians, you keep it. But remember, degrees into radians, always, always, always. So this is it. Thank you very much for watching this video, and I see you next time.